Okay, am I sharing screen with you guys already?
Yes.
Yes. Okay, thanks. Okay, so chapter 4. I keep jumping between chapter numbers here. I think my brain just isn't functioning well today. It must be the heat. Must be the humidity. Anyway, chapter 4, expressions and was it operators? Expressions and operators. So expressions is the main thing, and there are different things. I mean, declaring a function, declaring a variable we've already done, declaring a constant we've already done, and so on. But there's some interesting stuff in here about declaring objects and declaring arrays and how to add elements to arrays or objects. Um, and those kinds of things. So I mean, there's like entire chapters later devoted to arrays and objects and so on. But I think most of what you need to know about them, you can kind of find here, at least as regards objects. Arrays we will definitely go into more next week because arrays in JavaScript are special. It's a special kind of object. Um, and ever since 2016, there have been some really delightful methods that you can attach to arrays that allow you to filter or sort or just create new arrays from them. It's really turned into one of the really delightful things about JavaScript. So we'll definitely go into that some more. But as far as just basically creating arrays, the pre-2016 stuff, most of what you need is right here. So I'm just going to declare a variable here and set it to an array value. So you can do like an array. I'm going to kind of jump back and forth between this document and the console. The console, as you guys know, is for checking stuff. It's for checking values, typing stuff in, seeing if you can get a return or what kind of return it is, or checking the type of or instance of a variable or something like that. So let's just start over with the console real quick. But as far as what you guys submit to me at the end of this lab, it's just the stuff that goes into this index.js file. Like none of the stuff that runs that we type into the console, you don't have to copy and paste any of that anywhere. I'm not expecting to see any of that stuff. If it's important for us to record it in the document, then we'll do a console.log here. So we can get it to the console and it'll be part of our script. But otherwise, you won't have to worry about it. So going to the browser real quick here, to create an array, I mean, there's two different ways to do it. One is with, like, say, I don't know, let's say let r equals new array. And someone who works with a different kind of scripting language might be thinking, oh yeah, this is the way you do it. This makes perfect sense. And there it is. And then if I type in r, there it is. Now what it shows is an array literal, where it shows the square brackets around. Now I don't have any items in the array. I don't have any elements in there. So it's just an empty array, but it does exist. So I can actually do that by using the array literal punctuation instead of doing new array. So let me refresh that. Every time you refresh, remember that all the variables that you've declared get dumped out and swept up. So if I do r, like I'm getting, yeah, it doesn't exist. So instead of doing let r equal new array, I can do let r equal just this. Just the syntax, the punctuation that gets used in the rendering of the array. This is a shortcut for creating a new array in JavaScript. And so that does exactly the same thing. Now to create an object is exactly the same kind of thing. So if I say let obj, equal new object like this, which by the way, I can do it without the parentheses. I just don't. That object equals new object, and then if I do obj here, and once again, it displays it using the literal syntax, which means that I can use that same literal syntax in order to create a new object. Refresh the page again, and now if I do let obj equal, and just the curly braces now, instead of new object, and it works exactly the same way. So that might be a little bit different from other scripting languages that you may or may not be used to. So let's take a look at these in a little bit more depth. This time we'll pop back over to the script and let's declare an array there. So I'm going to say let a equals And we're going to use the literal syntax here, but we're going to give it some initial values inside of there. So an array is a numbered list of elements separated by commas, which can be any kind of value in JavaScript, really. But let's just go ahead and do some string values for 1, 2, and 3 to start with. So these are offset a little bit. If you've worked with arrays before, you know that this is actually the 0 item, and this is the 1 item, and this is the 2 item. But once again, non-coders are not going to be used to that. So I'm going to put in 1, 2, and 3 instead of 0, 1, and 2. So save this and pop back over to the console, and let's check it out. So I'm going to refresh. Every time you make a change to the script file, you got to save it, then you got to refresh the browser like this. It's I guess that's basically the equivalent of compiling something, right? It's setting up a new runtime where it reads the JavaScript one more time, and so it's able to get any fresh changes you make to the file. There's nothing surprising about that, I think. So if I type in A here, and there is the array. It's got 3 items in it, 1, 2, and 3. And if I drop this down, then I can see them arrayed. No pun. And there are the indexes, right? These are the keys of the indexes, 0, 1, and 2, and then here are the 3 values. And I can get individual items there by using the square bracket syntax. So if I want to get the first item, I say I want the first element in that array. So I need to give it the name of the array, and then square brackets again. And the first item is item 0, right? That's the key. So I put in the key in square brackets following the name of the array, and there it is. There's the first value. So I do A1, and I'll get the next one, and so on and so forth. I can also put these in quotes. This is actually, arrays are just kind of weird. I mean, it just looks like a numerical indicator or identifier, but it's actually an expression here. Just go away, would you? So I can put that in quotes. Sorry. I can put like quote 0, and look, it comes up with the same thing, which might seem kind of weird. Like, this is an integer, this is a number, and this is a string, so what gives? Well, JavaScript is really, really good at converting from one data type to another with implicit conversions. It's just one of the things that it does. It drives some people crazy. Some people like me love it. It's just up to you. So it's one of those things, and we'll see the same kind of thing to some extent when we talk about like enumerating our way through objects and so on. But it's something to be aware of. Now there's also the dot syntax that we will be able to use for objects, which we cannot use here. If I do a dot 0 like this, it's going to say, hey, an unexpected number there. I don't know what the heck you're talking about. Now I can change some of the values in here by using the same kind of syntax. Instead of calling it, I can assign something to it. So if I go back over to my script here, and I'll just do let's see, we've got 0, 1, and 2, right? So let's do A3 equals, oops. And let's give it a subarray here. So you can have an array inside of an array. So I will do 4 and 5, like so. So back over to the browser again, got to refresh. And there it is. So it's 1, 2, 3, and then an array. So again, if I kind of expand this out, and there it is, and there's an array inside of the array. You can do this with objects too. You can have objects nested inside of objects. You can have arrays inside objects. You can have objects inside arrays, and so on. Array is an object. Basically everything in JavaScript is an object except for the primitive values. So like an array is an object, a function is an object, a set or a map, those are all objects. And obviously objects are objects as well. So if we do like a 3 here, then it shows the subarray of 4 and 5. So that's the syntax for getting this done. If you want to add something to an array, then you can use the syntax to give it a number, or you can change one of these items in the array too. So if I do, like, say, A0 equals, I don't know, howdy, right? And go over here and refresh and check out A, Oops. Ah, where'd you go? There. Howdy 2, 3, and then the array. So yeah, that's for adding new elements to array and also changing the elements in an array. There are other ways to get new elements into an array as well, but there are methods on the array. They're push and pop methods. So I'm going to hold off on those until we talk about functions on arrays next week. Okay, so let's take a look at objects now. So objects have the curly brace syntax for the literals, instead of the square brackets. So let's do like a let O for object equal, and then we'll use the curly braces here. I tend to put these on multi-lines unless it's a really short object. If there's like one or two items in there, then maybe I'll do it on one line. But I will usually open it up into a multi-line code block here, just personally. So if an array is a set of items with numbered keys, this is a set of items with strings for keys. You can think of it as like a dictionary, like a lookup, like property value pairs or things like that. There's a shortcut in JavaScript in declaring the identifiers here, which are the property names themselves. They are strings, but you don't have to put quotes around them. And the reason why is because there's only one thing that property can be. It can only be a string. And so the people who wrote JavaScript said, well, if we know it's going to be a string, then why force people to write quotes around it? And you don't have to. So I could do like, okay, so I'm going to do like the reverse of the array. So the array is like, shoot, what just happened? Right, the array had the numerical indexes and then the string values to go along with it. And this time we're going to have the string properties and then the numerical values. So we'll do 1 here. And then just to be kind to ourselves, let's not do 0 here, let's do 1. So the property and value are separated by a colon here. This is like doing this, either with single quotes or double quotes or backticks or whatever. This is really what's going on. It's just that you don't actually have to put in those quotes unless you've got a space or punctuation or something like that. So if I have one called like 1 and a or something like that, then yeah, I would definitely have to put quotes around it in that case. Also, if I had like dashes in there, JavaScript is not good at handling dashes, so I would need quotes around that. But if it's just a single word string, like 1, for instance, then no, you don't need those in there. Just know that it's a string. So what if this was the only item in here? This is the only property value pair in the object. Is this going to work? Is this going to throw an error? Now, if you're coming from another C-based language, you'll probably say, yeah, that's going to be a big fat error because, look, there's a comma at the end of it. And there's no property value pair coming after the comma. It actually doesn't matter in JavaScript. Trailing commas are fine. So where'd the browser go? There it is. So what did we call this? Oh, there it is. No problems, right? It didn't have a problem with that trailing comma at all. You can do the same thing with the array here. Put a trailing comma and refresh and go A, and not a problem, right? So it's up to you. Some people they put commas after everything in one of these collection type things, and I could understand that because then you can copy and paste these all around each other, and you can just keep the commas with the values, and you don't have to worry about, oh wait, I have to add a comma here or delete a comma there or whatever. So anyway, this is one of those things. I think it's a personal coding style. You either put them in or you don't. It's up to you. Let's do 1, 1, 2, 2, and 3, 3, like so. Oops, that's something else I tend to do. That's a mistake. Like I can put a comma at the end of that, no problem, but I tend to want to put semicolons at the ends of like typing, but yeah, don't do that because that will cause an error. So back to the console, refresh. There's our object, 1, 1, 2, 2, 3, 3. And you see that this is all arranged on one line, and some people would code it that way as well. It really doesn't matter. White space doesn't matter hardly at all in JavaScript, like we talked about last Wednesday. It hardly matters at all. So let's use some of the same syntax that we used for the arrays in order to get some of these items. So I'm going to do O and then the square bracket thing, and then type in 1, and it doesn't like it. Remember that 1 is a string. Even though we didn't have to type in quotes when we were coding it, and it's not showing the quotes here, if we want to use it as an identifier, then we have to use the quote. And in fact, we're not using it as an identifier. That's the problem. It's thinking of this as an identifier. It's thinking, oh, there must be a variable called 1 somewhere, and there isn't. It's just a string. This is supposed to be an expression inside of here and not an identifier. So if you're using this square bracket syntax for this, and you've got a string, just remember that it is a string, and you put the quotes around it, and it works just fine then. However, we do pick up something that was not available to us in the array, and that is the dot syntax. Remember in the array, we tried doing, oh yeah, a dot 0, and it didn't work. Well, I can do this. I can do o dot 1, and looky there, I don't have to put quotes around it or anything. So both of these work. They're just different. I will say this, and this will have to do when we start working with loops and so on, especially. If we start renumerating our way through or enumerating our way through an object, then sometimes you need to pass a variable into this, like a variable of which you don't know the value yet, which that may not make sense right now, but hopefully it'll make sense later. In that case, we're going to have to use the square brackets, but without the quotes, and pass the name of the variable inside of there. You'll know when we get to it. I'll definitely remember that we have this conversation, and I'll say, okay, guys, this is what I was talking about here. That'll be with loops. Okay, so once again, we can add values to this by using the square bracket syntax. We almost always use the dot syntax for doing so, though. So let's say I do like, well, let's modify a value first. Let's say I do O dot 3, and instead of having the numeral 3, let's say O dot 3 equals math dot pi. Why not? And then I refresh over here and do O dot 3, and there's the value of pi. We've just changed it. You can also have objects that are nested inside of objects, just like we did like arrays nested inside of array. We did this, so let's go ahead and do this down here as well. Let's say O dot 3 equals, and we'll do another object nested inside of here, and we'll do like 3, and then math dot pi. The thing to remember, once again, is that this is not actually a numeral. This is actually a string. So the interpreter is looking at this as 3, like so. And you could actually type it this way if it makes it clearer to you. If we do that over here, and then just take a look at O, and once again we've got 1, 2, and then we've got an object for 3. We drop this down, and there's the prototype object, and so on. So it gets kind of messy after that. Oh, actually, no, this is 3 right here. So these are, yeah. So I didn't mean to go into here, but just note real quick that for objects, there can be a lot more stuff there than the stuff that we've typed in. And when you try to enumerate over the properties in an object, sometimes you accidentally get a bunch of this stuff into the return value, and it gets really messy. So just understand that. The other thing that's really important to note here is the thing that threw me off there real quick, which is the order of these. Like, we just asked it to show us, like, what does the object look like? And it says 1, 3, and 2 instead of 1, 2, and 3. It's an important thing to note in JavaScript. I have no idea whether other scripting languages are like this or not, but the order in which property value pairs are entered into an object in JavaScript, that has no guarantee that they're going to be read in that same order by the interpreter. So when you try to loop through an object, if you find yourself dependent on a particular order, then you'd best use a different kind of collection, like a map or something like that. So, good lesson right there. Make note of that. Objects can be read back in any order. Object properties, I mean. Okay, so this was all in the section 4.2 object and array initializers. That was all that stuff. So 4.3, or before we move on, any initial questions about Pan, about arrays or objects? Okay, so I think we'll encounter objects again as soon as this Friday, and then arrays, as I mentioned, we'll doubling down on those next Monday. The next one, 4.3, is function definition expressions, which I'm increasing that a little bit. I'm going to include, and in fact, start with a function declaration instead of an expression. So I'll tell you what the difference is here. So maybe I'll give myself a little comment here. I'm just going to say functions. Yay. Okay, so a function declaration is what was the most common way of creating a function once upon a time. I think that has reversed itself now, but I still use this with a fair amount of regularity, and that is simply to use the function keyword and then give us the name of the function, and then whatever I better not just call it name, but I'll function name, and then like parameters, arguments, if there are any, go in here. And then you have a code block in curly braces like this, in which you have the body of the function, the stuff that's actually supposed to happen when the function is called. So that's just a little bit of syntax. I'm not going to leave it like that. I'm going to do function, and let's say I want to do a function that gives me like the square, like the area of a square. If I give it a value, which is the side of one of the squares. I think this is one of the early examples you do in pretty much any scripting language. So like if I want to find out what's the area of a square with sides of 2, whatever they are, 2 feet, 2 inches, whatever, then I should be able to, just enter in 2 and have it give me 4, which is the area. So I will call this function square, and then the parentheses here, like you always have to have the parentheses there, even if you're not passing any values or any parameters into the function, you still need to have those there. In this case, I am going to have a parameter of the function. I'm just going to call this x. And basically what this is, in this case, the simplest scenario is this is what will be passed in as an argument when I call the function. So like I was just saying as an example, yeah, I want to find out what is the square of, like the area of a square with a side equal to 2. Well, I'm going to be typing in the value 2 here, and then hopefully get a response back out that will run that math function and give me what I need. And then the curly brace, the body of the function here. And there's more about this stuff, about jumps, returning values from functions, or breaking out of loops, or continuing loops, or that sort of thing. But I think return is something that like you're just going to need to know. Like you're going to use this all the time. So it's this keyword right here. And whenever you have this keyword inside of a function, the function will automatically stop running whatever code is inside the block here. Whatever code is inside the body of the function will stop. Even if I have other stuff down here, right? I've got other stuff that happens after that, but none of that will happen. It'll open up the function, it'll run whatever's before this, and then it'll see the keyword return, and bam, it'll pop you right out of that function again immediately. I think that can save you some heartache if you realize that and keep it in mind right from the beginning. And in addition to ceasing the running of a function and jumping you back out of a function or breaking you out of a function, you can get it to return a value. So in this case, it's very simple. I'm just going to return x times x, which is, of course, if I type in 2 here, go away. If I type in 2 up here when I call the function, then I want it to multiply 2 by itself in order to give me the area of the square. There we go. Notice this is not an expression. This is not a statement, so you do not put a semicolon at the end of this code block. Same thing with loops. So function square x, return x times x. Save this and just pop over here and give her a try. Return, and I should be able to call the function by doing the function name. And by the way, if I just do square without the parentheses here, what it does is it returns the actual function itself. So if I ever need to get the text of a function or something like that, type in the function name without the parentheses and log it to the console or whatever, and it'll give you this. If I do square with the parentheses, then it's giving me this weird thing here, NaN, which this stands for not a number. Basically what it's doing here is it's saying, okay, I'm seeing this asterisk and I know that this is a math operation, so this should be a number, but I'm starting out with a null value here, so I'm not getting a number, so I'm giving you nan, not a number. So let's now give it an actual value here. So square 2, there it is. It gives me the value 4, it gets returned from the function. If I do square 6, then I get an area of 36. So that's how the function works, and the function invocation, as it's called. So this is the function declaration, and then we invoke it, the function name, and then if we're passing in arguments into those parameters, I'll put an actual value in there. There we go. That'll give us the return value there. So I guess we could take this and do a console.log with it. So I'm going to show you 3 more ways to do the same kind of function creation. So we've just done a declaration of a function. The other 3 are going to be function definitions or function expressions, which are like creating a variable, right? Let A equal, and then you're using the syntax for an array or string or an object or whatever. But in this case, it's going to be a function. We're going to be like let variable name equal and then function. And then when you do that, you're not actually giving a name to the function itself. You're declaring what's known as an anonymous function, a function without a name, but then taking that function and assigning it to a variable name as an initial assignment. So let's check it out here. So here's the next way to do it. So this is going to be, the first one was declaration. This is going to be expressions as statements. So the simplest way to do it, and the way that has been around in JavaScript for a long time, is just declare a keyword, or sorry, a variable. I'm going to use let instead of var though. So I'm going to say let squares. So I got to call it something else a little bit because it does not want to reassign, like that same variable name. Give it a slightly different variable name. So let squares equal function. So this right here, this part of it, without the let squares equal, this is an anonymous function where there's actually just no function name, but just the keyword function in place of the function name. But other than that, we can do it the same way. So let squares equals function, and then pass it in a parameter there, and then same thing, return x times x. Now, I won't bother going to the console and testing this out, but you're welcome to right now or later. It should give you the same return. Well, in fact, I'll go ahead and do it. Save this, refresh the browser, and this one was called squares, and I will do squares 5 this time, and it returns the square value, right? So they do exactly the same thing. Which one's better? I don't know. I don't think one is better than the other. I think they're both pretty much the same thing. I guess that, okay, so a couple things. This is a statement, so put a semicolon there. Again, if you're going to be using semicolons. If you're not going to be using semicolons, this will still work, as you just saw in the browser, right? But if you want to be strict with yourself, then yeah, this one gets the semicolon, whereas this one does not, because this is a declaration and not a statement. So that's one thing. The other thing is just to notice that a function here, what we're doing in JavaScript is we're taking a function and we're storing it in a variable name. That means that functions in JavaScript are values, right? Because that's what variables are for. Variables are for storing values. So it's worth making a note of because not all scripting languages are like that. Functions are special kinds of things in most scripting language. They planted their flag in JavaScript very early on and said, you know what, we're going to say that functions are just values and they can be passed around like any other values. They can return values of their own or not, depending on what you need. You can have functions that are inside of other functions. They're called uh, function composition, or composed functions. You can even pass a function as a parameter into another function. So these are things that make JavaScript special. These are reasons why, some of the reasons why people like me are just huge adherents of JavaScript. For all of its quirks and all of its weirdities and weirdnesses and so on, it's just a wonderful little language to work with. So anyway, this is the first kind of expression to create a function. And note, by the way, that if you can put this into a variable, then you can put it into a constant as well, if you want to. But I won't, I'll just use let. Okay, number 2. So this is an ES 2016 thing. ECMAScript is the standards body for JavaScript. Believe it or not, there is one. And this came about in 2016, where we're able to use the arrow function, or the arrow syntax for functions. Instead of using the function keyword, we're able to use the equals arrow. Equals arrow, or the fat arrow, looks like this. Another place that this is used is when clicking a comment to let someone know what kind of value they can be expecting to return from like console.log or something like that. But that's just convention. That one doesn't matter. But in the case of declaring functions, it does. So check this out. This is pretty cool. And let's see, I'll do another one. Let's do squarely equal. And I'm going to have to do exactly the same thing as these other two. But I don't have to declare the keyword function here. Or yeah, the function keyword here. Just put in the parameter name that you're passing into it, and then the fat arrow, and then the code block, followed by the semicolon. So this guy right here, well, let me go ahead and put in the body here. So return x by x. This here does it. So it's not exactly the same as this one, but in this case it is. In this case, it's doing exactly the same thing. There are some differences between those two, but they have mainly to do with scope, and I'm not sure that we really have time for that discussion right now. That's scope and enclosures, or just closures. That's a really big, deep topic. Basically, it has, well, no, you know, let's not even go there. Just be aware there's something called closures, and there's something called scope, and function scope and all that we may or may not have time to get to this term. Okay, so that's this guy right here. This is an arrow function, or a fat arrow function. Same thing as here. If you have more than one parameter, so let's say we were doing x and y here, which we don't need, but then you would need to put parentheses around them. You need to do x and y like this. The other time when you might need parentheses is in those cases where you're not passing any parameter into the function. So let's say it's just like this, if we're not passing x in here at all. Then you would need to do one of two things here. You would need to either do a pair of parentheses, because you can't just do this. Like, that doesn't work in JavaScript. So an empty pair of parentheses would do it, or they give us an alternative syntax here where you can use an underscore, which I always thought looked kind of like a smiling person here. But yeah, the first time I saw this, I was like, what is that? You've got to be kidding me. But yeah, so you can actually do this one instead. You can use an underscore to indicate null value when you're passing in parameters in, you know, the arrow function. But in this case, we are passing in a parameter, so go ahead and do that. X, and with a single parameter, you do not need the parentheses there. Now, I said I was going to do a fourth way. Here's the fourth way, which is actually, it's going to be another one of these. It's going to be another arrow function. But as it turns out, they've given us a really lovely little syntactical sugar shortcut. If all we're doing is returning a value, then we actually don't even need the code block at all. And we don't need to use the return keyword either. Check this out. for this wonderful little, let's see, I love JavaScript so much. Let's see, I need another one. Let's do Foursquare. Let Foursquare equal, and this is an arrow function, so I don't need the function keyword to do X, and then there's my fat arrow, and then just the value I want to return. Like, really? Like, yeah, that's all you got to do. If all you're doing is returning a value, then, and you put it on the same line like this means, yeah, return this value from this function. So here's our original expression. Take a look at that guy, which doesn't seem bad when you first look at it, and somehow I managed to get rid of that. I need to get that back in there. It doesn't look too bad when you look at it, but then you compare it to this, and you're like, oh yeah, this looks way better. Let's try it here. I want to make sure this thing works, right? Because it just, like, there's no way that it actually works. Let's go over here to the browser, and I'm just going to do Foursquare 8. Oh, Foursquare is not, what did I call it? I didn't save this. Or I didn't refresh this or something. See, that happens when I get too excited here. Foursquare 8. And look, it works. How about that? I bet you've never worked with any scripting language that had something as concise as that. To declare a function and return a value from a past variable on one line of code. This is what they're working on in ECMAScript. They're working on including more and more of this very simple sugary type syntax that enable us to get away basically from our C roots, right, for this kind of thing in order to do stuff like this. And in that same spirit are some of like the functions on arrays that we'll see next week. Okay, my goodness, how are we doing? It's 7:30. We've been at this for I guess about an hour and 15 minutes now. Let's see, are there any other things that we need to know about functions? Let's see, gosh, there's dates. Well, no, we already did dates in the last chapter here. Let me just check my notes here real quick. I want to make sure I'm not missing anything. I guess the last thing about functions, which I'll go ahead and finish this stuff up. Hang on just a second. Yeah, let's just do methods real quick here. So methods are functions that are stored inside of an object. If you recall, the objects are up here. And the property names are strings, and they have to be. There's nothing else those can be. We probably will not get a chance to look at maps or sets in this term, but map is like an object except that it is, you know, in a certain order, and the properties can be anything. Like you can have a function as a property name, or like a number, or as a property name, or another object, or whatever. But simple objects like this, it has to be a string. But then the value can be anything. As far as I know, it can be anything. It can certainly be a function. And so you can have a function as a value of a property inside an object, and then you can call it the same way that we call the properties. So recall that with this one, we were able to see like O.3, right? And it gives us this nested object, which is the value of the 3 property, which is a string in there. But what happens if we do it as a function instead of an object or another string or something like that? So let's go ahead and do that. First of all, let's declare a function here where we'll be logging a string to the console. So I will do, I'll go back to the old function declaration here. So function howdy, and this one I'm not even passing a variable in, so it's just like empty parentheses there. If this were an arrow function, we wouldn't even need to include anything, but in this case we still need to have those there. Or actually, no, we would have to have the empty parentheses there. But anyway, function howdy, and then you don't need to actually open up the code block. You can have it on one line like this, and I'll just do a console.log howdy. And there we go. And again, no semicolon because it's just a declaration. If I go over here and refresh, and howdy, and there it is. And then we do howdy with parentheses. and it spits howdy out to the console. So I'm going to do, I'm going to create another object here, and we're going to store this function and one other one. We're also going to create a function called later that's logs later to the console. But this one we will bring in from outside the object. The other one we will type in as we're creating the object. So let's say let greetings equals, and then we'll use the object literal, so curly braces. I'm going to put the semicolon at the end there. And the first one here, doing howdy. Now note that there is a function called howdy outside of here, and we're making another identifier called howdy inside of here. This is perfectly fine because howdy inside the object is a string and not an identifier at all. I mean, it's a property, but it's a string, so it's perfectly fine. And let's do, well, let's just say howdy. So this is something that you actually see a lot. This is a pattern you see a lot, which just seems kind of weird at first, where you've got like, wait, this stands for this. Wait, what? What are you doing? But yeah, just remember. I'll get rid of this thing then. Yeah. This one stands for this object out here, and this one is a new string property that's being added to the greetings object. So gotta have a comma if we're separating two things here. And the reason I want to put this into the object itself instead of having later as another function outside of here and doing it the same way is because I want to show you another nice sugary syntax that IS450 gave us. So let's do later, and I'll do it like the old-fashioned way first, right? Which is like this. Start out the same way with the later string identifier or property name, and then an anonymous function in here, just like we did up here for howdy, but we will do console.log later. So go ahead and save this like it is right now. So there's a function as the value of the later property. Actually, for both of these properties have a function. So if I go refresh in the browser and I do greetings dot howdy, it shows me, oh, yep, there's a function value there. And now if I do it with the parentheses, oh, greetings, plural, there we go, it gives it howdy. So this is how you call a function that is the value of a property in an object, which is also referred to as a method. So this is a method, which is just a particular kind of function. In fact, it's not even a particular kind of function. It's just a function that's placed in a certain place. It's placed inside that object. So we're able to do the same things with later. So right, greetings.later. And if we leave it like this, it will return the function script, put the parentheses, and it will actually spit out the return value. So now I want to show you the fun part. I mean, this is already kind of fun, I think. But let's comment that out, okay? Because I want to show you a cooler way of writing this. In 2016, or 2018, I think this was 2016, they gave us some nice sugar here, where instead of writing later colon and then the function keyword, I can treat this as if this is the function name, and just put the parentheses right on there, and then just follow it by the body of the function, console.log later, like so. And this may look weird, like, wait, where's the colon? How is this separated into property and value? Like, what in the world is going on here? Well, it's just one of those things that they were able to get in there because they realized, yeah, if we can make it so this is only ever interpreted in one way. We're going to take whenever we see something like this, and the interpreter is going to interpret it as if it's this. So I don't know about you guys, but I think that's awesome. And I'm just going to, well, I guess I'll leave this comment. Go ahead and leave this comment in there for yourselves so that you know that, oh yeah, this is what this is doing. So for you guys, leave the comment in there, but I'm going to get rid of mine because I just want this nice neat version like this. Let's test it because surely something so cool wouldn't actually work. And let's do greetings later. Oh my. It works. It's alive. Boom. Do that in C++. There's so little left to go here. I'm going to skip past some stuff so that we can get finished with this chapter right now. So I don't have to split up, like, say, chapter 4, part 1, and chapter 4, part 2. We'll just do the whole thing right now. But we've actually done almost everything that is really important, I think. There's some other stuff. There's instance of, which is important. So definitely don't skip over this stuff in your reading. Well, you're already done with the reading, but I don't want you to skip over this stuff necessarily. But just as far as the demo goes, we'll skip past the instance of and like some of the. Well, no, I guess we better not. Okay, let's go. I'm going to go ahead and declare a pause here and a break. And there is actually a little bit left in chapter 4 that we'll do because we want to look at some operators just a bit. And then we'll do operators, and then we'll jump into some of the chapter 5 stuff so I can get you started on that before you need to do the reading for Friday. So any questions about all the stuff that we just did here? So arrays, objects, and functions is basically what we've done. Okay, cool. If you think of any questions in the meantime over the break, feel free to ask them later on. I'm going to stop the recording here.